Hello, my name is Alberto Pascal, and in this video I will be showing you my approach to the solution of the degrees problem. First of all, I'd like to talk about some important changes I made. I made use of a Q-frontier to represent a breadth-first search and guarantee that I will always find the shortest path, even though this also means that some searches might require a higher processing power. Secondly, I did not make use of the pre-built function contains state. I used dictionaries instead, and this was due to the fact that when handling the large dataset, the lists on contains state would become really big and slow down the searches. And finally, I added some validations to make sure I can skip unnecessary searches. And all of this was with the objective of reducing my search time. Regarding my validations, I divided my validations in two, which were before expanding and after expanding. Before expanding, I only ask if I am the target, and this is to identify if I'm searching for myself or if I am already in the solution node. And after expanding, I search if the current neighbor is the target, which allows me to skip unnecessary searches on my frontier because I know where the answer is. I search if my neighboring node has already been seen or explored, and I also check if my neighboring state has already been explored. And this is because I might not come across the same node twice, but I can come across the same state more than once. Regarding the examples I will be showing you, I will be making use of Tom Hanks with Tom Cruise, Sally Field and Carrie Elves, Juliana Costa and Julian Vance, which I think is a pretty good example because it is one of the largest searches I could find, and between Kevin Bacon and himself. So let's take a look. Here's my terminal. We will start with the small dataset. And here I can type Tom Hanks and Tom Cruise, for example, and there is the solution. Here's the print I was talking about. I am skipping unnecessary searches because I noticed the solution was one of my neighbors, and this translated into searching only 7 states and saying that my solution was 2 degrees of separation. So we can run this example again, and let's say I want to go for Kevin Bacon with Kevin Bacon, and here is I only explored 1 state because I identified that I am myself. So there are 0 degrees of separation. Now, when dealing with a large data set, we have a pretty similar behavior. Mainly the difference will be in the amount of states I have to explore because the large data set has a much bigger database of people and movies. So let's say we can search here for Sally Field with Carrie Elves. And there it is. It was also a quick search, but this time I explored 45 different states, and even though I explored more states, my solution was still 2 degrees of separation. But this will not always be the same. So let's say I can also load the large dataset and search for myself, which I will be doing right now to show you that I can still identify that I have 0 degrees of separation. And there are also some other cases I want to explore, which result in much more states. So let's say here, I want to search for Tom Hanks with Tom Hanks. And there is 1 state only, which are 0 degrees of separation. Now, the last example I wanted to talk about was between Juliana Costa and Julian Vance, which is the largest search I could find. I did not run this during the video because when using the contains state function, it takes around 3 hours to find a solution. And when using the dictionaries and validations I implemented, it still takes around 12 to 15 minutes. So here it is. This is where I searched for Juliana Costa and Julian Vance. I added a print to show the progress on these explored states. And I finally found a solution after having explored around 357,000 different states. My solution was of 8 degrees of separation. So that would be it. Thank you all for watching and see you on my next video.